This lesson will cover Big Idea 1, Standard 2. Topic for today is models of the atom. So our first model of the atom comes from John Dalton. And Dalton discovered that matter is composed of atoms. Which is true. Dalton also thought that atoms of the same element are identical. Which is not entirely true. So the element carbon, for example, is made up of all carbon atoms, but not every atom is identical because we know there are isotopes. And isotopes are not identical because they have different mass numbers. Dalton also thought that atoms cannot be divided. So Dalton's model looked something like this. He thought the atom was as small as it got. There weren't any smaller components making up the atom. After Dalton came J.J. Thomson. Thomson improved upon Dalton's model because Thomson was the first to discover that atoms contain smaller particles with positive and negative charges. So what Thomson's model looked like is we had a region of positivity. And in that, he thought that there were negatively charged particles embedded into that positively charged matter. Thomson's model is called the plum pudding model. So plum pudding is probably something that most of us are not familiar with. So the example that I like to use is a blueberry muffin. So if you think about a blueberry muffin, the actual muffin part of it is kind of like that positively charged material. And then you have blueberries embedded throughout that muffin. The blueberries are like those negatively charged particles. So you have this region of positivity, and then you have all of these negatively charged particles embedded into it. Just like we have this muffin with blueberries embedded into it. So since we're not familiar with plum pudding, think of this more like a blueberry muffin. So after Thomson came Ernest Rutherford. What Rutherford found was that our negatively charged electrons, he thought they move around the nucleus like planets around the sun. What Rutherford also found is that the atom is mostly empty space. This is also the first time that we have a positively charged nucleus. So let's look at the Rutherford model. So he thought we had a positively charged nucleus. And again, this is not drawn to scale, but he found that there were electrons, and he thought that they moved around the nucleus like planets around the sun. After Rutherford comes Niels Bohr. So Bohr improved upon the Rutherford model because he discovered that electrons travel in energy levels. So in the Rutherford model, we have all of the electrons orbiting around the nucleus like planets around the sun. So what Bohr figured out is there are actually different energy levels that the electrons can travel in. So we still have our nucleus in the middle, but now we have electrons in different energy levels. Bohr still thought that the electrons are moving like planets around the sun. The Bohr model is going to be the model that we are going to see most often. And the reason that we use Bohr models to represent the atom is because they are easy to see, they're easy to interpret. I could clearly look at this model and see the number of electrons that we have. I could see there are 2 electrons in the first energy level, 4 electrons in the second energy level. So the Bohr model is going to be the model that you're most typically going to see when we're talking about atoms. However, the Bohr model is not the most accurate. The most accurate representation, our current representation of the model, is what we call the quantum model. This is a mathematical model that calculates where an electron is likely to be found. This model is much more complex. So let's say this is an orbital. It's a region where an electron is likely to be found. An electron can be moving 3-dimensionally anywhere within that orbital. We can also have a larger orbital. And again, the path of the electron, it's not going to be moving around the outside 2-dimensionally like planets around the sun. The electron can move 3-dimensionally anywhere within this orbital. So again, we can see how this is getting much more complex. These first 2 orbitals are spherical in shape. We also have orbitals that we call like a barbell or a dumbbell shape. And again, the electrons can be moving anywhere within that orbital. Again, think of electron movement kind of like bees buzzing around all over the place. So this model, as we can see, is much more complicated. So even though it is the most accurate model we have based on our current understanding of the atom, typically what we're going to see is the Bohr model because it's a lot easier to interpret what's going on.